Hello and welcome to this class on run length encoding compression. The previous class we looked very briefly at compression as a whole, why we use it, and the two different types of compression that can be applied to a file that we want to reduce in size. And we want to explore that a little further. And in this class, we're going to look at RLE, or run length encoding. And if I was to try and sum up run length encoding in a sentence or give you a definition, yeah, that's quite hard without an example. But I would say it's a method of compression that looks for repeating patterns. Let me explain. So I need to share my whiteboard again. Okay, so run length encoding then, what's it all about? Or we often see it referred to as RLE, run length encoding. Well, it is about looking for repeating patterns. So if I have a binary string of, say, this, I'm just randomly typing ones and noughts out, okay? We want to compress that down. And we're going to use RLE to do it. Now, the way we do it, we start at the beginning and start looking for repeating characters that are the same. In this case, we have 4 ones. So that's what I'm going to write. We have 4 ones. Okay, we next have 3 zeros together. So, okay, 3, 0. We carry on this method. We've got 2 ones next, so that's what I'm going to write. 2 ones, followed by 1, 2, 3, 4, 5 zeros. 5 zeros. I won't make you sit through the whole lot, but you get the idea. You get the idea. And that's run length encoding in a nutshell. So this is this binary string compressed as RLE. So what I can do, I could send that to you. Okay, I'm going to send that to you. And what you could do, you can then unpack it at your end. So you can look along and say, ah, look, I've got 4 ones. So that's what I'm going to write, 4 ones, followed by, looks like 3 zeros. So I'm going to write 3 zeros, followed by 2 ones. Sorry, that's me. There we go, 2 ones and 5 zeros to end it with, okay? And look at that. We're able to unpack it and get back to the original. Now think back to the previous class. Is RLE lossy or lossless compression? If you said lossless, you would be correct. It is a form of lossless compression. And that's because the key point here is that we're getting back to the original. We can unpack it and get a complete version of what was originally compressed to start with. So RLE, run length encoding, is a type of lossless compression. It works great on binary, as we can see. It does reduce it down character-wise, but it's not one of the most effective methods. But that's lossless compression as a whole, isn't it? That's one of the disadvantages. It does reduce things down, but not by a huge amount. But it works better in binary, as you can see. It also works on words. So let's pick a word, or it can work on paragraphs and all sorts, okay? But let's just pick a word. Let's pick the word football. Now, football is an interesting word. You'll find if you're taking GCSE computer science, football is a word that's used quite a lot, especially when it comes to dealing with compression or answering questions on compression. You'll see that the word football is used quite a lot in questions. So let's compress this with RLE, shall we? So we've got 1F we have 2 O's, we have 1 T, 1 B, 1 A, and 2 L's. Okay. I send that to you, and then you can unpack it at your end. So we work our way along, and we can get back to the original word, which is football. As you can see, it hasn't really compressed it that much, but when you start to understand that each letter might be 8 bits of information, you can see how it might have reduced that word down a little bit. But yeah, football, a good example to use in this case. We can also use pixel colors, for example, with RLE. That quite often comes up as an example or a question. And what I mean by that is, oh crikey, how am I going to do this? Right. So say we got various colors like so. We can use RLE to compress the color information. So we might have 2. Oh, crikey! 1 second. There we go. We might have 2 red and 3 green, for example. That sort of thing. So it's quite versatile. The main advantage of run length encoding is that it's simple. It is simple, isn't it? It's a simple method, and once you've seen an example, you can fully get on board with it. You understand what it's doing just by seeing just one example being shown once, and you're away. Basically, it is simple. It is a simple method of compression, but as we noticed, it's probably not the most effective way of compressing something down. But yeah, that's run length encoding, a nice simple form of compression that uses lossless. It's lossless, if you remember, because we're able to get back to the original. In the next class, we're going to be looking at a more effective means of compression, one that's also a little bit more tricky, a little bit more difficult. Okay, but I hope you found this class on run length encoding useful. Okay, take care. Thank you very much.